My name is Natalie, and I am a horticulturist here at the Conservation Garden Park. And so now we are going to move into our Switch to Drip class. So some of the things that we are going to talk about is why you would switch from spray heads to drip, what the types of drip are, and how to actually go about making that conversion. So when you have spray heads in planting beds, there are a few problems that can occur. The spray often gets blocked by plants as they grow and get bigger and keeps anything behind that plant from getting the necessary water that those things need. When the spray heads are also attached to a zone that waters lawn at the same time, the plants in the planting beds don't need as much water as the lawn, and they don't need it as frequently, and so they tend to get overwatered, which if it's too extreme can kill plants. It also leads to increased weeds because you're putting water on the surface, which is where the weed seeds blow in, and so that helps them germinate and grow, and so it creates more maintenance for you with weeding. It also can increase the disease and fungus potential in your plants. We actually, this past year, have had a fungus in some of our 9 barks in the garden, and it was way worse in the areas that are still on spray heads that have not been converted to drip. And we know that this is a problem, that spray heads in planting beds are a problem, partially because we have some at the garden from when it was first installed. And we are slowly working to switch ours to drip as well. So some of the ways to overcome these problems is to put your planting beds on drip irrigation. This planting bed is on drip and has been for quite a few years, and we don't have as many weeds in this area, and the plants are beautiful. If you do the drip right, you don't have to worry about them not getting enough water, and it can really be a pleasant area to be in. So the first thing that you need to figure out when you are thinking about putting in drip is you need to know what type of soil you have. Most of Utah has more clay in the soil, but there are some areas that have more sandy soils. And as you can see in this diagram, the water moves very differently in the types of soils. So in clay, it takes a lot longer for the water to soak in, and it spreads out more and doesn't go as deep. With sand, it soaks in way faster and doesn't spread out very much and goes a lot deeper. And with sand, with either type of soil, once the water gets past where the roots are, the roots can't really take it up anymore, and so that's just wasted water. So you need to water according to the type of soil that you have. In order to figure out what type of soil you have, a quick way to do it is to do what's called the ribbon test, and there are some instructions that you can find online on ways to do this. But just quickly, you get some soil in your hand, get it a little bit moist. You don't want it super wet, but you want it to be able to kind of stick together a little bit. Well, if you have clay, it'll stick together a lot more than if you have really sandy soils. And then if you can squeeze it through your fingers, like in the picture on the right, then it is an indication that you have more clay in your soil. If it just crumbles and falls to pieces and doesn't create that ribbon, you probably have more sand. If you want to get a professional soil test done and find out for sure what type of soil you have, you can go to the website on this page, usual.usu.edu, which is for the USU Analytical Lab, and they will do soil testing, and there are a bunch of different things that you can get the soil test for, and depending what soil test depends how much it costs. But the basic ones are $14 or $30. And I believe both of those would give you the information that you need, but you would want to check what those tests are actually checking for, so that you know that you're getting the soil type. All right. So with that, we are now going to talk about the different types of drip. So inline drip has emitters that are built into the line at specific intervals. And so you need to know what soil type you have before you go and buy inline drip, if that's what you're going to use, because the type of soil you have determines how far apart you want those emitters. And if you go onto a manufacturer's website, it will give you more information on what the spacing on those emitters should be. But generally for sandy soils, it's more in the 12-inch spacing between emitters. And in the clay soils, it's more like 18 inches. With point source, it has a distribution tubing that's just blank. It's just a tube, and you push your emitters into that line wherever you need to water the plants. When you are deciding what type of drip to use, if you're going to use inline drip or point source drip, you can look at the density of plantings in that area. So if your planting bed has lots of plants and they're pretty close together, or you have lots of trees and shrubs, then inline drip is a good option for that. Where if you have very few plants and they're spaced a lot farther apart, then you could potentially do point source. And we will talk a little bit more about each of these and how to actually install them. But first, every drip zone needs a pressure reducer and a filter. So there are a couple of ways that you can get the pressure reducer and the filter. One is in a retrofit head kit. And then the other is that you can put one either at the valve or somewhere along the PVC line before you split off to your actual drip line. So the goal with these is to get the pressure down to 20 to 30 psi. As that's what the drip is going to work best at. If it's much above 30, it can blow the emitters and make it so that they just run freely and aren't holding back the water and dripping it slowly for the soil to take in the water. And you might get some runoff and have some other issues that way. So you definitely need a pressure reducer and a filter. If you have a secondary water system, you'll need to rinse out your filter and clean it a lot more frequently than if you have a culinary system. And to do that, you just unscrew the top, pull the filter out, swish it around in a bucket of water, and put it back together. So if you are wanting to put the pressure reducer and filter at the valve, but there's not room in your valve box, then you can get a little bit creative and add another box either by the valve or closer to where the drip is going to come out of the line, and add the pressure reducer and filter there. I would highly, highly, highly recommend putting it in a box though, and not just burying it in the ground, so that you can get to that filter to clean it out if needed. All right, so another thing to be aware of is that spray heads and drip run for very different amounts of time and at different pressures. So spray heads typically run at 30 to 50 psi, and the drip runs at 20 to 30. The fixed spray heads, like is shown in this picture on the lawn, also run for about 20 to 30 minutes, maybe every 2 to 4 days, where the drip will run for in the heavy clay soils that we have here at the garden, we run it for an hour or maybe a little bit more than an hour once every 7 to 10 days generally in most of the garden. So because of the difference in how frequently and how long to water, you need to have them on separate zones. So in this picture, you can see that the sprinklers are on, but the drip that's in the planting beds will come on at a separate time. It doesn't come on at the same time, so that they can water just what the plants need in that area, because the lawn needs a lot more water. All right, so if you are going to use a retrofit kit, they're pretty easy to use. Depending on how big your zone is and how many of those you would need, it may be cheaper to do the one at the valve. It would be something to at least look at pricing wise. But the first step for using a retrofit kit is to unscrew the cap of an existing spray head that's already in the ground that is spraying in that planting bed. And then you unscrew the cap and you pull out the top with the riser and the internal spring. So you just leave the sprinkler head body, just the casing in the ground. And then with the retrofit kit, it comes as a sprinkler head looking thing. And so you remove the pressure reducing cap and the filter, and add those to the spray head body that is in the ground still. And then you screw it on, and once that is all assembled, you can connect the drip line to that pressure regulated filtering head. And then you use pins or staples to help hold the drip line in place, and keep it where it needs to be. It also helps keep it under the mulch, so that you don't see it, and it helps reduce the weeds, because it's watering just the soil and where the plants can actually access the water and where they need it. And then once you have all that done, you need to remove all the other spray head caps and risers that are on the same zone, and then replace those with the spray head cap that has a gasket in it. So it will, that's what's showing here in this picture, is one of those caps for the spray head that doesn't, it's just solid on the top and won't allow any water to come out. All right, so you need to cap all of the other spray heads in the same zone as the drip, because they cannot run at the same time. Otherwise, you're going to really underwater part of it or really overwater other parts of that zone. So one option is to cap all of the other spray heads with these types of caps, or if the type of spray head that you have doesn't have caps that go with them, you can unscrew the entire head and remove it and cap the pipe that is underneath. If that's the case, the retrofit head may not be compatible with your spray head bodies as well, and you can remove the entire head and just put the whole retrofit kit head in its place, which would screw onto something like this underground. When you're using inline drip, you want to get the lines laid out as evenly as possible. And you want that spacing to be the same as whatever your emitter spacing is. So if your emitters are 18 inches apart based on your soil type, then you would want your lines to be 18 inches apart. If your emitters are 12 inches apart, then your line should be 12 inches apart. So you just want to match the emitter spacing with your line spacing. And a way to help you do this is to use a piece of pipe or a stick or something that is cut to the proper length, and then use that to help you space the lines as you go. All right, so when we're actually laying out inline drip, we generally start with kind of a border or a frame around the outside. And then here's the showing where the lateral line, the PVC or poly pipe would come in and connect into the drip. So after we have the perimeter in place, we add in the lines evenly spaced and then connected on both ends so that if there's a kink in the line somewhere, it can still fill from the other side and hopefully not lose any watering efficiency. And then you connect that to the lateral line over here. And you can connect it first and then run your drip, or if you're low on time or budget, you can lay out your drip first and leave your spray heads running, and then once it's all laid out and ready to go, then you can connect it into either your retrofit head or directly into a pipe. And with this, again, the emitters are built into the line at evenly spaced intervals, and you need to buy the spacing based on your soil type. And since they're laid out in this grid pattern, it is designed to create an even distribution of watering. And it soaks in underground and spreads out a lot more. Especially if you have the clay soil, that's why the emitters are farther apart. Where the sandy soil, since it doesn't spread out as much, the emitters are closer together. And if you offset the emitters on each row, it creates a more even distribution. But it's not something that we generally worry about here at the garden. It just kind of tends to work itself out that way. So, but it does seem like it would be more efficient that way. But generally the area will be getting evenly watered anyway, and the roots of plants spread out quite a bit, and so they'll still get the water that they need. And this shows kind of how the water moves from each emitter to cover the entire area. So the grid does not need to be at right angles. What I just showed you in those animations is the ideal, but we do not live in an ideal world. And a lot of times our planting beds are not perfectly rectangular, and there are plants already in them, because this is a switching to drip class. Likely you already have planting beds that are on spray that you're looking to retrofit, and so they come in all sorts of different shapes and sizes, and the drip is very adaptable to that situation. Try to keep your lines as evenly spaced as you can, but they can bend and follow the curves of whatever planting bed you have. So after you have the drip lines in place, then you want to cover those drip lines with 2 to 4 inches of mulch. It helps hide the lines. It also improves the efficiency because it helps hold the moisture in the soil, and it also helps reduce your weeds and maintenance, because the weed seeds that blow in will be on top of the mulch layer, where the water will be underneath that mulch. And so they're not going to get as much water as they might need to germinate. You will still get some weeds. No matter what you do, you will still have weeds, but this will greatly help reduce those weeds, especially if you can weed the first couple of years and keep things from going to seed, so that the weed seeds that are down by the drip will germinate then, and you'll have to pull those. But other than that, after that, it should greatly reduce the amount of weeds you have. After it's covered with mulch, when it turns on, you'll see something like this for where the water spots are. Don't worry about where you put your plants. With this type of drip, you can put your plants anywhere in the planting bed and it will get evenly watered. So even though you only see circles on the surface, underground it spreads out and creates that even watering. With point source, the emitters plug into distribution tubing and can go directly to individual plants. And as the plants grow, you can either change out the emitters or add more emitters to match the plant needs and give them the water that they need. So point source also needs a filter and pressure reducer or regulator. So this type of multi-outlet retrofit head accomplishes that and can be used as a retrofit. And with this, the lines push directly onto the retrofit head. This is a demonstration that we have here at the garden. And so in this, you can see how the lines attach. If you are going to bury this underground, I would recommend putting it in a small valve box so that you can access it and make repairs and make sure that the tubes are still attached, and get to the filter to clean it out. But generally, in the garden at least, we have them kind of on the soil surface like you can see in this picture, just barely above the mulch, so that they're still accessible, but they're not in a box. So either way works, but just remember, if you're going to bury it, put it in a box so you can access it. Manifolds can be screwed onto threaded couplers. These do not have filters or pressure regulators in them. And so you would need to, if you're using this type of manifold, you would need to put a pressure reducer and filter somewhere in the line before you get to this point. So it could be at the valve box or beside the valves or wherever it needs to be before this line comes out, to have it pressure regulated and filtered. And this is what they can look like when they're actually in the ground. And with these, if you have just a few plants in an area, these can give you still some open spots. So you can see one kind of here on the right side of the picture, and then one down here on the rock that have caps on them. They don't have tubes on them yet. But as this shrub grows, if it needs more water, we could attach more lines to those to give it more water. These can screw onto threaded couplers, either where spray heads were or onto one of those retrofit heads to water some pots in an area or something like that. So with point source drip, if you are using distribution tubing with the emitters punched into that, you would have your planting bed and your lateral line, and then you would make a connection to the distribution tubing and run that to where you want it. And then you would add your emitters every 18 inches for clay soil or 12 inches for sandy soil. And then with trees and shrubs, you probably don't want emitters less than 2 gallons per hour. So here's our trees and shrubs. But then as they get bigger, you need to increase how much water those trees are getting. And so you can increase the gallons per hour for each emitter, and then as the tree gets even bigger, you might need to add more emitters as well. So if you have an area that is planting bed, and it is watered separately from the lawn, so it comes on at a different time than the lawn, but it's all just planting bed, then since they need to run for different amounts of time, this is the best scenario, because then you can just add a retrofit head and cap all of the other spray heads in that zone. And the spray in your lawn is still going to water, and then the planting bed will be on the drip. So all of the yellow circles are capped heads, so they won't spray anymore. And then the red circle is a retrofit kit with the drip line attached that has the pressure regulator and the filter in that, and then you can just run the drip line straight from there. If your planter bed and lawn are on the same zone, it will take a little more work, but you can add another valve with a pressure reducer and filter, and then you can run your pipe out to your planting bed and add your drip line from there, and then just cap the spray heads that were in that planting bed, and you would switch like this blue circle, you would switch that to spraying a quarter instead of a half, because it wouldn't need to water the planting bed anymore. Another way that you could do this, if you didn't want to add a new zone, is that you could take out the grass and make that all planting bed as well, and just switch the whole thing to drip. But the key thing is that you need to keep drip separate from spray heads. And there are ways to do that, as we just talked about. We also have other irrigation classes that talk a little bit about this. And so you can watch those on either the Conservation Garden Park YouTube channel or on the Localscapes Teachable page. So with that, that is the end of what I have for my presentation. So if we have any questions that we need to answer, Sean, or anything, we can do that now.
Cool. Thanks, Natalie. Great presentation. We've had some questions come in. We've been able to answer a lot of them, but a few that I've seen come in recently have to do with the Retrofit Kit heads. And it seems like they're asking how much water is actually pushing through those. Like, okay, so here's the first question. How many feet of inline emitter line can you run continuously off of a sprinkler head retrofit kit? I think they're kind of wondering, is that putting out enough water to have a big drip irrigation system?
That is a good question. There are a lot of factors that go into how much drip line you can run off of one source, including pipe size leading up to that and what the flow is through the system. And if, okay, so it's not something that I know the specifics on, but if you go to a manufacturer's website, they might be able to tell you for that particular type of drip. Or if you talk to someone at like a sprinkler house, they might be able to help with that. If your planting bed is fairly large, you may need to put multiple retrofit kits on that zone. So you may have one at one end and one at the other end, so that you get more flow through the line. You can still connect all those lines and have it be a continuous loop with just 2 water sources. But yeah, I'm not sure on the exact number of feet that you can use off of one retrofit head.
Yeah, my guess is that in a residential setting, someone would be hard pressed to have a drip zone big enough that would push the limits of a retrofit kit or a long runs of drip line.
Yeah.
Because we haven't really pressed the limits too much here at the garden with what we've done, and our zones are a lot bigger than what people would have at their own house. So
Yeah, that's true.
yeah, probably not an issue that you're going to run into a lot in residential situations. Although one scenario that does come to my mind is what we've run into there's a planting bed island in our parking lot for the garden. And we're starting, so it used to be on spray, and we switched it to drip irrigation probably a couple years ago. And it's got a slope to it. There's a high side and a low side to the parking lot island, the planting bed. And we've noticed that after we switched to drip, the trees on the high side tend to brown out faster than the trees on the low side. And Natalie, correct me if I'm wrong. I think the thing we're thinking is there may not be enough flow distributed evenly through the planting bed because the change in elevation.
Yeah, it's a pretty big planting bed, and I think we put 1 or 2 retrofit kit heads on it. So it just might not be enough flow because there's a lot of line in there. There's a lot of linear feet of line. So we may, I think we've discussed adding another retrofit head towards the top of the slope so that we can try to get more flow into the line and then also get more water to those areas up top. But as long as you have enough flow, you should be fine. And like Sean was mentioning, we started noticing it because the plants were telling us that something was wrong. So if you watch your plants, they'll kind of indicate when they're not getting enough water. One warning though with that, signs of overwatering and underwatering are the same. So if you notice your plants struggling, go out and feel the soil around them and see if it's wet or dry before you change your watering.
Sounds good. We've got a few more minutes here and a couple more questions that have come in. Can you use one connection? I assume they mean one valve that has drip line on it to water plants that are in the ground and plants that are in containers.
That's a good question. I would recommend no. Generally, your pots or containers are going to require more water more frequently than plants in the ground will. So I would recommend having them on separate zones so that you can water the plants with just the amount of water that they need. So you're not wasting water and increasing your water bill.
Sounds good. I know one concern that people have with this process is if they have to add like another valve with drip line just for their containers, it might be difficult to do and get it attached to their sprinkler clock. There's actually sprinkler clocks that are small now that fit in your valve box with the valves, and they're Bluetooth operated, so you can operate them with your phone. So you can install a new valve for your drip line that's watering your containers, and you can install this new sprinkler clock that's tiny. It just attaches to the valve in the ground, and you just operate it with your cell phone, run the schedule with that, and then that way you don't have to run sprinkler wire all the way back to your clock for that new valve. So that is an option that can help you.
Yeah, that's a good point. And those can work on either type of drip and anywhere in the yard, really.
Yeah, it's a great option.
Mm-hmm.
I think I've seen recently that it may be Orbit, it may be Ratio, it may be both of them or others, that they're coming out with the small clocks like we're describing that can actually communicate with your main clock if it's the same brand. So I know that's a technology they're working on.
Yeah.
Can you go over briefly, maybe one more time, how to find out whether the soil is sandy or clay?
Sure. Let me get back to that slide. Okay. So a quick way to do it at home is called the ribbon test. If you need more instructions than this, if you just Google it, you should be able to find some instructions as well. But you just get some soil in your hand, get it a little bit moist, kind of squish it together, see if it clumps up. If it creates a pretty firm clump, and you can squeeze it through your fingers and create a little bit of a ribbon with it, it's probably more clay. If it just kind of falls apart and doesn't really hold together and doesn't create a ribbon and just crumbles, then it's more sandy soil. If you want a more scientific way to figure out your soil, what type of soil you have, you can get a soil test from the USU Analytical Lab. And yeah, you can get a soil test that will tell you what type of soil you have as well.